Hello and welcome to this video on arc length and sector area. We are starting out by looking at a circle in front of us with a central angle and a center point at 0. That central angle is the angle BOA, and it is measuring 60 degrees. The radius of our circle is 2.5, and you have two different radius lengths drawn to the outside of the circle from the center point O. Now, our goal here is to kind of derive the formula for how you would find the length of this orange arc right here from B to A, this minor arc BA. And the first thing we would think about would be to think about what would it be in degrees. There is a theorem for circles that the central angle, whatever you have central angle is 60 degrees here, that means that the arc it hits is also the same amount of degrees. So you could say that arc BA is 60 degrees. Now that we have established that, we want to figure out, well, if our radius is actually not just 2.5, we would want to think about what would it be specifically? 2.5 what? So we would say 2.5 inches, for instance. And we can label both of our radius lengths with inches. And now we can be specific in what we are talking about. Now, if I wanted to now find the length in inches of this arc, I need to think about, well, what percent of the circle is this arc if this angle is a certain percent of the whole circle? So the first thing I need to figure out is what percent of 360 is 60 degrees. So we can write that out. So 60 degrees is what percent of 360 degrees. So depending on your level of comfort with this sort of problem, it could be easy or hard. And the main idea is if we're trying to find 60% is what percent of 360, we would be able to kind of make a little proportion. So I would do 60 degrees over 360 degrees would be equal to an x% over 100. When you solve this proportion, you just do 60 times 100 and then divide that by 360, meaning that x is going to be equal to 16.7% approximately. So that is the first thing we would need to find. To go along with that, we need to find the whole circumference of this circle. We know the whole circle is 360 degrees. Now we need to find the circumference if our radius is 2.5. So we know the circumference formula is 2 pi r. So now I'm going to do 2 pi times our radius of 2.5. And that is going to be equal to about 15.7 inches for our circumference. Now, what we've basically found here is that we know that our angle is taking up about 16.7% of the whole circle. So that means this arc, which is also 60 degrees, is 16.7% of the whole circle's circumference. So in order to get my answer, all I would need to do now is find 16 point, or no, not 16, it is 15. So yeah, 16.7% of our circumference of 15.7. And to find that, all we need to do is just make our percent into a decimal, which would turn into 0.167. And then multiply that by our circumference to get our final answer, which is going to end up being about 2.62 inches. 62 inches. 2.62 inches is our final answer for this example. Now, before we move on to sector areas formula, we want to kind of generalize this to work for every problem. So the first thing you would basically do is that, well, we had to do 60 out of 360. That equals 0.167 if you put in your calculator. So that's the percent part. 60 out of 360. So we know that is the percentage part. That's where the 16.7% came from. And then we would multiply that by our circumference, which is this part where the 2.5 came from. So then I would be multiplying it by 2 pi times 2.5. And that would also equal our same final answer. Now, the last thing with arc length before we end this portion is we won't always have 60 degrees and 2.5 inches for a radius length and angle measures. Frequently in math, you see this Greek letter right here, which is called theta, representing unknown angles. So that would be what the 60 is. And I would be able to kind of generalize this to be theta over 360 and then multiply it by our circumference of 2 pi r. And that would be the arc length formula in terms of degrees. Now let's look at developing our sector area formula. First, a sector is basically this pie slice from our circle where it goes from point B to point O to point A and then across arc AB. And that piece right there out of the circle represents a sector. So the process is very similar in that we need to find what percent of the whole circle is this one little sector area. So the first step would be finding the percent of the circle 60 degrees is. We've already found that. We know we can do 60 over 360 and find the percent the 60 is of 360. We already know that 16.7% approximately. So we know that this 60-degree sector will take up about 16.7% of the whole area of the circle. We want to know the area of this little sector. So we would need to figure out, well, what the area of the whole circle would be first. So then I would have to do my area formula, which is pi r squared. So I would do pi multiplied by 2.5 squared. That gives me an answer for area of 19.6. And I'm almost there already. I can take this 16.7% as a decimal, and that decimal would end up being equal to 0.167. And then I can find 16.7% of 19.6. And that would give me the area of my sector. And that would equal about 3.3 inches squared for the area of this little pie slice sector. Now, if I wanted to generalize this to a formula, I could take this fraction, 60 over 360, and then I am getting the percent from that part, the 16.7%, and then I'm multiplying that by my area of pi times 2.5 squared. And that gives me my answer for sector area, which ends up equaling 3.3 as we saw above. And then generally, if we want to write out our sector area formula, so to find the area of a sector, we would just replace the 60 and the 360 with a theta for an unknown angle, as I mentioned earlier. Theta over 360, and then you just multiply that by pi r squared. So you'd be finding what the percentage of the circle's area, which would represent the area of that sector. And that covers the formulas for both arc length and sector area in this video. Thank you for watching.